So students, now let's start activity 13.2 sample space for the event tossing the coin. So our objective for this activity is to write the sample space when a coin is tossed once, 2 times, 3 times and 4 times. So students, now let's start the method of construction for the given activity. First, take a drawing board. And fix a white chart paper on it. Toss a coin once. When we toss a coin once, it can have two outcomes. That is head or tail. Make a tree diagram on the chart paper. So the tree diagram, when a coin is tossed once, that is there are two outcomes, heads or tails. Write its sample space. Again, in step 5, again toss a coin twice. It can have four outcomes. So it can have four outcomes. And now write its sample space. Repeat the experiment of tossing the coin three times, 4 times, and so on up to n times. And write the sample space possible. So in step 6, repeat the experiment of tossing the coin 3 times, 4 times, up to n times and write the sample space that's possible. So students, now let's see the demonstration for the given activity. If a coin is tossed once, then the sample space is S equals to H T. So the number of elements in S is equal to 2. We can also write 2 to the power 1. That is, when a coin is tossed once, it is either head or tails. That is, 2 outcomes. When a coin is tossed twice, the sample space is S equals to, so when a coin is tossed twice, the sample space, this is the tree structure to represent the outcomes when a coin is tossed twice. The outcomes are HH, that is heads, HT, TH, that is tails, and heads, that is one time tail and one time head, and the last tails both the time, TT. Number of elements in S equals to 4, that is 2 to the power 2. So students, when a coin is tossed 3 times, the sample space is Now first let's draw the tree structure when a coin is tossed 3 times. This is a structure when a coin is tossed once. This is the structure forming when a coin is tossed twice. This is the tree structure for that. Now, but in this case we need the tree structure for the coin tossing 3 times. So this is the tree structure for the 3-time tossing of the coin. So our sample space S is equal to H heads, HT, that is heads and tails, HTH, HTT, THH, THT, TTH, that is tails and heads. Now TTT, that is all the 3 times we get a tail. So this is the sample space when a coin is tossed 3 times. So the number of elements in S is equal to 8, which can also be written as 2 to the power 3. So the number of elements in S is 8, that can be written as 2 to the power 3. 3 denotes 3 times. Now in fourth step, when a coin is tossed 4 times, then the sample space is S. So first let's draw the tree structure for. So students, this is the tree structure when a coin is tossed 4 times. So the sample space S is equal to H, that is 4 times heads, H, T, 3 times head, and 1 time tail. Second, H, heads, tails, and heads. Then heads, tail. Now heads, tail, heads, tail, heads, tail, heads, tail, tails, heads, tail, tails, heads, tail, tails, tails. That is 1 time head and 3 time tails. Next, tail, head, heads, 1 time tail and 3 time heads. Tail, heads, tails. Tail, heads, tail, heads. Tail, heads, tail, tail. Next, tail, tails, head, head. Tails, tails, head, tails. Tails, 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 heads. Tails, 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 4 times tails. So this is the complete sample space when a coin is tossed 4 times, and the number of elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the number of elements in S equals to 16, that is 2 to the power 4. In the similar way, we can find the sample space for the coin tossing more number of times by constructing their tree structure and finding their sample space. So students, now let's see the observation for the given activity. First, number of elements in sample space. First, when a coin is tossed 1, equals to 2 to the power 1. Second condition, when a coin is tossed twice, then the number of elements in sample space is 2 to the power 2. Third, when the coin is tossed three times, then the number of elements in sample space is 2 to the power 3. Fourth, when a coin is tossed four times, when a coin is tossed 4 times, then the number of elements in sample space is 2 to the power 4. As we will find out in our demonstration, it is 2 to the power 4 equals to 16 elements.